All right, the second part of this chapter is about the concentrations of solute, molarity, molality, mass percentage, and mole fraction. What is molarity? You know a little bit about it from Chem 1. You know that molarity is the moles of solute per liters of solution. I want you to know these types of formulas for the exam. These are not going to be provided. So you need to know what is molarity, and you know the abbreviation for molarity is uppercase M. Mass percentage. Mass percentage is the percentage, right? It's grams of solute per grams of solution. I will write solution like this in the abbreviated form to save time, times 100%. So it's as usual that what you expect from percentage is parts per total. The next, let me just go over the, okay, molality. Molality is something that you did not have before. Molality, so far you have molarity, now you have molality. And you need to know its abbreviation is different. So you distinguish with uppercase M and lowercase m between molarity and molality. Molality is, again, moles of solute, but instead of talking about solution, we talk about kilograms of solvent. Not grams, kilograms of solvent. You need to use them and memorize them the same exact way that they are shown. And the last concentration unit is mole fraction. Mole fraction does not have any unit because it's the division of moles. So your mole fraction is the fraction of moles of solute. Moles of solute per moles of solution, right? All right. So now we are going to work on some questions about each of these molar concentrations. So the first question, let's talk about molarity a little bit. I'm working on the first question on slide 38 of your PowerPoints. An experiment calls for 36 grams of a 5% aqueous solution. When we say aqueous solution or aqueous solution, whichever you pronounce, means that your solvent is water. So an experiment calls for 36 grams of 5% aqueous solution of potassium bromide. Describe how you would make up such a solution. When the question is asking for how you would make up the solution, means that you need to explain how much of solute and solvent you need. So 5% aqueous solution means 5 grams of KBr in how many grams of solution? 100 grams, right? So 5 grams KBr plus how many grams of water if the total is 100 grams? Don't forget, solution is solute plus solvent. So if your solute is 5 grams, how many moles of solvent or water do you have? 95 grams, huh? Now, we will use this ratio to determine the mass of KBr in 36 grams of solution. So we are going to express how many moles or how many grams we need to dissolve in water. So we need the mass of KBr. So you know that you have 36 grams of solution, right? It's a 5%. So it's 5 grams of KBr divided by 100 grams of solution. Now you can cancel grams and grams of solution to find the mass of KBr. 1.80 grams of KBr. And so 1.80 grams. And the total, this is the solute, right? You need to find out what mass of water to take. The total is 36 grams of solution. So minus 1.80 grams of KBr. What is the mass of water? 34.2 grams of water. So means you need to measure 1.80 grams of potassium bromide on the balance, and then you add 34.2 grams of water to it, you mix it, then you will have 36 grams of a 5% solution of KBr. All right. The next question is about molality. We're covering them one by one, and then we work on their relation with each other. Molality. Lowercase m. Moles of solute per kilogram of solvent. The question I'm working now is from slide number 41 of your PowerPoint slides. Iodine dissolves in a variety of organic solvents. For example, in methylene chloride, it forms an orange solution. What is the molality of solution of 5 grams of iodine in 30 grams of methylene chloride, which is CH2Cl2? Now, I always suggest you to be organized, write down what you have, and then think about what you need. What do we need? The molality. Molality means what? Moles of solute per kilograms of solvent. So you need to build the top and bottom of fraction and then plug them in. You already have which one is solvent? You need to determine solute and solvent also. Methylene chloride is the solvent, and solute is I2. So what do you need to find for solute? The number of moles. So go ahead and use the molar mass of iodine, 5 grams. On the PowerPoint slide, on slide number 42, you have the solution all together, like the solution for this question is all together in one formula, but you can also break it down to 2 formulas, doesn't matter. 5 grams of iodine, and we know that 1 mole of iodine is 253.8 grams. Don't forget it's I2, so it's 2 times 127. And then you will get the moles. Now for the bottom, you have 30 grams of solvent, and you know that 1 kilogram, 1 kilogram is going to the top, to the bottom. 1 kilogram is going to be 10 to the third grams. Now you have, I'm messing it up here, 1 kilogram is 10 to the third grams. So you can cancel this, and at the end you will have, the answer will be 0.657 moles per kilogram. I hope the answer is correct. I'm just copying from the PowerPoint slide. So basically, again, you need to build it. You need to build this fraction for yourself. The next unit is mole fraction. We show it with X. I told you it does not have any units, and it's moles of solute per total moles of solution. So in the questions, if you need to find a mole fraction, you need to have the number of moles of both. The question on slide 44 of your PowerPoint slides is talking about mole fraction. A solution of iodine in methylene chloride, again, the same thing. 5 grams of iodine and 56 grams of methylene chloride. 56 grams of methylene chloride. So it's asking for mole fraction of each of the components, I2 and CH2Cl2. So since you need the mole fraction, so you need the moles of each of them, right? You need to use the molar masses. Well, how much was it? 253.8 grams. So how many moles will you have? 0.0197 moles of iodine. And for methylene chloride, 1 mole of methylene chloride is 84.93 grams. So you will have 0.694 moles of your solvent. Now, mole fraction is moles of solute, 0.0197, divided by total number of moles, which is 0.0197 plus 0.694. This is for I2. And it gives you 0.029 for iodine. For CH2Cl2, you have 0.694 divided by 0.097. Or you could have added these two just like what you have on PowerPoint slides first and then use that number. And you will have 0.971. Keep something in mind, that X of solute plus solvent must be equal to, or very similar to 1, very close to 1. So 0.029 plus 0.971 is almost 1. Keep it in mind because you need it later. All right. Now, you learned about these 4 concentration units. It's time to move around and try to convert them to each other. That would be a big part of your questions. I'm working on page 47, slide number 47 of your PowerPoint slides. It says a bottle of bourbon is labeled 94 proof, meaning that it is 47% by volume of alcohol in water. So 47 milliliters in 100 milliliters means 47 milliliters in 100 milliliters. And let's change them to the liter. You know that each liter is 1,000 milliliters, so let's change both of them to 470 milliliters in 1 liter, right? Since 1 liter is 1,000 milliliters. So, means that you have 470 milliliters of alcohol in 1 liter of solution. So 470 milliliters of alcohol. And 1,000 minus 470 is 530 of water. Okay. Now we are supposed to find the mole fraction. So we need the moles of alcohol and moles of water. The density of ethyl alcohol is given, so that's the key. You know that we have 470 milliliters of alcohol, and the density of alcohol, which is given, is how much? 0.80 grams in 1 milliliter. And since you need the number of moles of alcohol, go ahead and use its molar mass right away. 1 mole of alcohol, or let's say C2H5OH, that's ethanol, 46.8. In the exam, all the formulas of the unknown substances will be given, don't worry. So it gives you 8.16 moles of alcohol. It's time to find the moles of water also. How many milliliters of water do you have? 530 times 1 milliliter. We know that the density of water is 1 grams per milliliter. So again, we use its molar mass. 1 mole of H2O, if you calculate it, is 18.02 grams. So it gives you 29.4 moles of water. Now, total moles is, let's add them here right away, plus 29.14. 0.4, I'm sorry, which is 37.6 moles. And now at the end, you're looking for the moles of mole fraction of ethanol. Moles of ethanol was 8.16 divided by the total, which is 37.6 moles total. So it gives you mole fraction of ethanol as 0.22. I hope the calculations are correct. I'm just copying from PowerPoint slides. The next question on slide 49 is very similar, so you should be able to work on it. Again, asking for a mole fraction. The next question I'm working on in this video is from slide number 52. A solution contains 8.89 times 10 to negative 3 mole fraction of I2 . in 0.9911 mole fraction of, we used I2 and methylene chloride a lot in this chapter. It's a good example. What is the molality of I2? What is the molality of I2? What do we need for molality? Let's find out what we need to build. Molality of I2 is moles of I2 divided by kilograms of solvent, right? Which one is solvent? Determine solvent as solute first, so it will make it easy for you to work on the questions. Solute was I2 and solvent was CH2Cl2. So moles of solute per kilogram of solvent, right? So if we assume that the total sample, didn't we say the mole fraction of solute plus mole fraction of solvent is total is going to be 1? I just told you, and I told you that you need it later on. So we have and if you add them to each other, you will have almost 1. So we work with 1 mole solution. Sorry. So moles of solute, we already have it. 8.89 times 10 to negative 3 moles. And kilogram of solvent, you need to find it now in order to be able to plug it into this formula. Kilogram of CH2Cl2. What is given to us is 0.9911 moles. It's time to change it to the mass by using its molar mass. Molar mass of CH2Cl2. 1 carbon, 2 hydrogens, and 2 chlorines, as you did for the previous examples. 84.93 grams. And you need the kilogram of solvent. So go ahead and change it to kilogram right away. 1 kilogram is 10 to the 3rd grams, or 1,000 grams. Excuse me. Which will give you 0.08417 kilograms of CH2Cl2. So now you are ready. You have 8.89 times 10 to negative 3 moles divided by 0.08417 kilograms. Excuse me, I don't know what happened. All right, so the molality is going to be, according to what I copied from PowerPoint slides, it's going to be mole per kilogram. That's how you work on this type of questions. Okay, then you have 2 more examples of working on conversion between the concentrations of the problems, that going from molality to molarity, which you should have a clue of how to work on them. So let me know if you have any questions, and in the next video I will talk about colligative properties, working on 4 colligative properties.